Hi students, myself Kale SL, Rayat Shikshan Samsthas, RBNB College, Srampur. 11 Science Mathematics Part 2, Lecture number 7, Chapter number 7, Limits, Exercise 7.4. In the previous video lecture, we have completed Exercise 7.1, 7.2, 7.3. Today we start here Exercise 7.4, which depends upon limits of trigonometric functions. So let us see what is the concept of limits of trigonometric functions. Now here, limit as x tends to, suppose 5, limit as x tends to 5 sin x. Now see here, in the denominator there is 1. So we put directly the value of x as 5, that is, it is equal to sine of 5. In place of x we put 5. Or if we have here limit as x tends to 45, suppose, and sin x upon x, here in the denominator x, but if we put x as a 45, denominator not equal to 0, so we may put directly x as 45, that is equal to sine of 45 upon 45. We know the value of sine of 45, that is, it is 1 upon root 2 divided by 45, and so it is equal to 1 upon 45 into root 2. We can put here the value of x directly if denominator not equal to 0. Now here suppose limit as x tends to the 0 and sin x upon x. So this is the formula for limits of trigonometric function. Limit as x tends to the 0, sin x upon x, it is equal to 1. Okay, and here another formula here, limit as x tends to the 0, tan x upon x, it is also 1. These are two very important formulas in limits of trigonometric function. We may take here x or theta. Okay, so limit as theta tends to the 0, sin theta upon theta, that is equal to 1, or limit theta tends to the 0, tan theta upon theta, that is equal to 1. We may take here limit as x tends to the 0, x upon sin x, x upon sin x, then also here its value is 1. Here also limit as x tends to the 0, x upon tan x, then also here the limit is 1. So we use these two important formulas, limit as x tends to the 0, sin x upon x, that is equal to 1, and limit x tends to the 0, tan x upon x, that is equal to 1. Now we start here exercise 7.4. Question number first, evaluate the following limits. Evaluate the following limits. First problem, limit as theta tends to the 0, limit theta tends to 0, sin m theta upon sin m theta upon tan n theta, tan of n theta. This is the first problem. Now just we have seen here formula, limit as theta tends to the 0, sin theta upon theta, that is equal to 1, or limit theta tends to the 0, tan theta upon theta, that is also 1. Here we may take theta or x. So here tan theta divided by theta, and that theta should tends to 0. Here also angle is theta and divided by same, that is sin theta upon theta, and that theta should tends to 0, then the value is 1. So we have to adjust here angle of sin and angle of tan in this problem. Here sin of m theta divided by here should be m theta. Here tan of n theta divided by should be here n theta, to use these formulas. So commonly we have to divide numerator and denominator by theta. There is need to divide numerator and denominator by theta. So it is equal to limit as theta tends to 0, we divide numerator, that is sine of m theta, and here this tan of n theta. We divide numerator by theta and also denominator by theta. We take the same operation on numerator and denominator. Now here we want here m theta, so here must be m theta, because here theta upon theta. So m theta upon m theta, so I adjust here m and cancel this m, so into m suppose here, so this m and m get cancelled. Now here also tan of n theta, so take here n theta, we adjust here n and cancel this n by multiplying this n and n get cancelled. And now here we separate the limit to numerator and denominator, and now this m and n, these are constant, we take outside the limit, so it is equal to, in the numerator here m and in the denominator here n, so m upon n into, we take here limit as theta tends to 0 to numerator separately sine m theta divided by m theta, and in the denominator limit theta tends to the 0 tan n theta divided by n theta. Okay, now the value of this using this formula, it is 1, but in the formula here theta divided by theta, sine theta divided by theta, theta tends to 0. In this problem here m theta, sine of m theta upon m theta, but here theta tends to the 0. So here we have to write, since theta tends to the 0, when theta tends to the 0, ultimately m theta also tends to 0. If we put m theta as 0, so m into 0, that is 0. M theta tends to the 0. Also here n theta tends to 0. N theta tends to 0. If we put theta is equal to 0 in this n theta, it approaches to 0 or the value is 0. So here instead of writing here m theta tends to 0, here theta tends to 0, we can use. Now the value of this using this formula is 1, the value of this denominator is 1, and therefore we get here m upon n. So it is equal to m upon n, numerator is 1 divided by denominator also 1. Here we have to write these formulas here, and so it is equal to, solution is m upon n. Okay, so in this way we get the solution of the first problem. Now we see here second problem. Limit theta tends to 0. Second problem, limit theta tends to 0. 1 minus cos 2 theta upon theta square. 1 minus cos of 2 theta upon theta square. This is the problem. Now here, since these are the problems depending upon trigonometric functions, we have to use formulae of trigonometric functions. Okay, so 1 minus cos of 2 theta, we have the formula of cos of 2 theta. Cos of 2 theta is equal to 1 minus 2 times sine square theta. There are 4 formulas for cos of 2 theta, but we use here cos of 2 theta is equal to 1 minus 2 times sine square theta, because in the limit we know limit theta tends to the 0, sine theta upon theta is equal to 1, or tan theta upon theta, that is also 1. So we convert this problem either in sine theta or tan theta, and so we use this formula, cos of 2 theta is equal to 1 minus 2 times sine square theta. Carry this 2 times sine square theta to left side, so 2 times sine square theta is equal to 1. Carry here cos of 2 theta on the right hand side, it is minus cos of 2 theta, and so we get here 1 minus cos of 2 theta, that is equal to 2 times sine square theta, and so we write here solution as limit as theta tends to the 0, numerator we replace by 2 times sine square theta, 2 times sine square theta upon this theta square. Okay, now here sine square theta upon theta square, so limit as theta tends to the 0, this 2 as it is. This numerator square upon denominator square, we write numerator upon denominator whole square. like this. A square upon B square is equal to A upon B bracket square. So we write here sin theta upon theta bracket square. And now take this limit inside the bracket. So we get this 2 outside the limit constant, and we write here limit as theta tends to the 0 sin theta upon theta bracket square. And we know that the value of this is, we have seen formula, limit as theta tends to the 0 sin theta upon theta, that is equal to 1. Always write here formula. So value of this is 1. So 2 into 1 square. It is equal to 2 into 1 square. 1 square is 1. So 2 into 1, that is equal to 2. The solution of this problem is 2. Now we see here third problem here. Limit x tends to the 0. Limit x tends to the 0. X tan x upon 1 minus cos x. X tan x upon 1 minus cos x. Now here in the denominator 1 minus cos x. If we put here x is equal to 0 in the denominator, 1 minus cos 0, cos 0 is 1, cos 0 is 1, so 1 minus 1 0, denominator becomes 0. So we have to solve using our previous method also. We rationalize this denominator. That is here limit as x tends to the 0 x tan x upon this 1 minus cos x as it is, and rationalize this denominator. We multiply by 1 plus cos x divided by 1 plus cos x. Okay. And now here in the denominator these are conjugates. So 1 minus cos x into 1 plus cos x. Use the formula. So limit as x tends to the 0. In the numerator here x tan x as it is, and this 1 plus cos x as 1 plus cos x as it is, right in the bracket, because this is the addition of 2 terms, so we take in the bracket. And here use the formula a minus b into a plus b. A minus b into a plus b, that is equal to a square minus b square. And so we get a means here 1, so 1 square minus cos square x, 1 square minus cos square x. So we get here limit as x tends to the 0. Here x tan x, in the bracket here 1 plus cos x divided by this 1 square means 1 minus cos square x. Using first fundamental identity, it is sin square x, because we know that sin square x plus cos square x is equal to 1, and therefore we carry this cos square x on the right hand side. We get sin square x is equal to 1 minus cos square x. So 1 minus cos square x is sin square x. And now here limit x tends to the 0, and here tan x and sin x is present, so we have to use here standard formula, tan x upon x, x tends to the 0 1, or sin x upon x, x tends to the 0 1. In the numerator here tan x, but in the denominator sin square x, so we have to divide this denominator by x square. Since here square, so we have to divide by x square. So we divide denominator by x square, and so divide numerator also by x square. We have to take the same operation on numerator and denominator. So divide a numerator and denominator by x square. So we get here limit as x tends to the 0 x tan x upon x square. We divide numerator by x square. Also denominator, that is sin square x upon x square, and this 1 plus cos x as it is, 1 plus cos x as it is. Now we separate the limit to numerator and denominator. Now here this x and x get cancelled. Okay, so this is equal to limit as x tends to the 0 tan x upon x, tan x upon x. Also separate limit to this 1 plus cos x also. So limit as x tends to the 0, 1 plus cos x. And in the denominator, limit as x tends to the 0, here sin square x upon x square, we write sin x upon x bracket square, and take limit inside the bracket also. So we write like this, limit as x tends to the 0, sin x upon x bracket square. Now these are the standard formulae. Limit x tends to the 0, tan x upon x, it is 1. Limit x tends to the 0, sin x upon x, it is also 1. Write these formulas here, since limit as x tends to the 0, tan x upon x, that is equal to 1. Also limit as x tends to the 0, sin x upon x, that is also 1. So it is equal to this 1 into here 1 plus cos of, put the value of x is 0, so cos of 0 divided by here, this denominator is 1 and it's a square, so 1 square. Now I remove this formula. So it is equal to this 1 plus cos of 0 is 1. Here 1 square is 1. 1 plus 1, 2, 2 into 1, 2, 2 upon 1, that is equal to 2. So the solution of this problem is 2. So in this way we have completed here third problem. Now we see here fourth problem. Limit x tends to the 0. Limit x tends to the 0, sec x minus 1. Sec x minus 1 upon here x square. Here also we rationalize numerator. So it is equal to limit as x tends to the 0, sec x minus 1 divided by x square as it is, and multiply by sec x plus 1 divided by sec x plus 1. And so it is equal to limit as x tends to the 0. Now in the numerator use the formula a minus b into a plus b, that is equal to a square. A means sec x, so sec square x minus b, b means 1 square, and 1 square is 1, so there is no need to write here 1 square, write only 1, so minus 1 upon this x square into this sec x plus 1. Okay, now here we have seen third fundamental identity, 1 plus cot square theta. Second fundamental identity, 1 plus tan square theta is equal to sec square theta. 1 plus tan square theta is equal to sec square theta. This is second fundamental identity, and third one is 1 plus cot square theta is equal to cosec square theta, but here there is sec square x, so we have to use this fundamental identity. 1 plus tan square theta is equal to sec square theta. Now here carry this 1 to right hand side, this plus 1 become minus 1, so sec square theta minus 1, that is equal to tan square theta. So sec square x minus 1, that is tan square x. So it is equal to limit as x tends to the 0. Here it is tan square x, sec square x minus 1, using this fundamental identity, tan square x upon this x square as it is into sec x plus 1. Now here for this tan square x upon x square, we use the standard formula. Only we write this square and this square in tan x upon x bracket square. Okay, so it is equal to limit as x tends to the 0, this numerator square upon denominator square, we write tan x upon x bracket square into this sec x plus 1, we write separately, that is 1 upon sec x plus 1. Now we separate the limit to this and this. So we get here limit as x tends to the 0. We take limit inside the bracket. Limit as x tends to the 0, tan x upon x bracket square into limit as x tends to the 0, 1 upon sec x plus 1. And now here we use standard formula. Which formula here? Limit x tends to the 0 tan x upon x, that is equal to 1. So for this, solution of this round bracket is 1. So 1 square into 1 upon sec x, sec of, put x as 0, sec of 0 plus 1. So it is equal to 1 square is 1 into 1 upon sec of 0. Sec of 0, it is the reciprocal of cos of 0. We know that cos of 0 is 1. So 1 upon cos of 0, 1 upon 1, that is 1. So sec of 0 is 1. So we get here 1 plus 1. Okay, 1 into this, so 1 upon 1 plus 1, and it is 1 upon 2. So solution of this fourth problem is 1 upon 2. Now we start here. Question number 2, evaluate the following limits. Question number 2, evaluate the following limits. First problem here, limit x tends to the 0. Limit x tends to the 0, 1 minus cos nx, 1 minus cos nx divided by 1 minus cos mx, 1 minus cos of mx. In the previous question, in example question number 1 and example number 2, we have seen the formula of 1 minus cos of 2 theta. 1 minus cos of 2 theta, that is equal to 2 times sin square theta. We have used this formula in problem number 2 of question 1. Now here it is 1 minus cos of nx. Okay. So here if we divide this angle by 2, divide this angle by 2, so this is also divided by 2. We divide angle by 2. So 1 minus the 2 and 2 get cancelled. 1 minus cos of theta is equal to 2 times sin square theta by 2. And now replace theta by nx. We replace theta by nx. So we get here 1 minus cos of theta by nx is equal to 2 times sin square nx divided by 2. We replace theta by nx, and here replace theta in this formula, replace theta by mx. So we get here 1 minus cos mx is equal to 2 times sin square mx divided by 2. So we get these formulas. So we write this as limit as x tends to the 0. So 1 minus cos of nx, that is equal to 2 times sin square nx divided by 2. And in the denominator it is 2 times sin square mx divided by 2. Here mx, so mx divided by 2. Now these 2 and 2 get cancelled. So it is equal to limit as x tends to the 0. In the denominator, here sin square mx divided by 2, and in the numerator it is sin square nx divided by 2. Okay. Now here x, here x. So we divide numerator by x square and also denominator by x square. Why x square? Because here x square, here square means square of this, mx divided by 2 square. Sin, here sin square x means it is not the sin square, it is sin of actually x square. But we write here this square, this place. So sin square x means here it is x square. So sin square mx upon 2 means the angle is mx divided by 2 bracket square, means here x square. So we divide by x square. Commonly we divide by x square to numerator and denominator. Okay. Now, so it is equal to limit as x tends to the 0. This square and this square we write in the same bracket, that is sin nx divided by 2 divided by x and whole square, and here divided by sin mx divided by 2, this mx divided by 2 and divided by x, because this square and this square we write sin mx divided by 2 upon x and bracket square. But here observe, we have the formula limit theta tends to 0 sin theta divided by theta divided by theta tends to the 0, value is 1. So angle of sine is theta and in the denominator should be theta. Here angle of sine is nx upon 2. So here also must be nx upon 2. Out of that x is present, but n upon 2 is we have to adjust. So I adjust here n upon 2. I adjust n upon 2. We have to multiply here n by 2. We have to cancel this n by 2. So we multiply by n by 2. But here n by 2 in bracket square. So here we have to adjust by n square by 4. Okay. Similarly, in the denominator, here angle is mx upon 2. Out of that, here x is present, but m by 2 we have to adjust. So we adjust here m upon 2. Now we have to cancel this m by 2. So we multiply by m by 2. But here square. So here m square upon 2 square. 2 square means 4. In this way, we adjust the angle of sine in the numerator and denominator. And now here we take limit as numerator and denominator separately. Here this n square upon 4 and m square upon 4 which are constant, take outside the limit, that is n square upon 4 divided by m square upon 4. And now we take this limit x tends to the 0 inside the bracket directly, that is limit as x tends to the 0 sine of nx divided by 2 and divided by nx divided by 2 bracket square, and in the denominator limit as x tends to the 0 sine mx divided by 2 divided by mx divided by 2 bracket square. And now observe here sine nx divided by 2 and divided by nx by 2 means the angle of sine is same, and this should be tends to the 0, but we know that as x tends to the 0, this nx upon 2, see here nx upon 2, this is equal to n, put the value of x as 0, so n into 0 upon 2, n into 0 upon 2, that is equal to 0, means here nx upon 2 also tends to 0, and also in the denominator mx upon 2, mx upon 2 also tends to 0 because x tends to the 0, and using the formula, which formula? Limit as theta tends to 0 sin theta upon theta, that is equal to 1. Okay, here also we have written that formula. So the value of this is 1 and this also 1. So we get here, now we cancel this 4 and 4. So we get n square upon m square into this 1 square upon 1 square. So it is equal to 1 square is 1, here 1 square 1, 1 upon 1 that is 1, into this n square upon m square, we write it as n upon m bracket square. So this is the solution of this first problem. Now we see here second problem. Second problem here, limit as x tends to pi by 6. Second, limit x tends to pi by 6, 2 minus cosec x, 2 minus cosec x divided by cot square x minus 3, cot square x minus 3. Now in the paper first we have seen fundamental identities. We know three fundamental identities. That is, first one is sin square theta plus cos square theta, it is equal to 1. Second one is 1 plus tan square theta is equal to sec square theta. And third one is 1 plus cot square theta is equal to cosec square theta. Okay. In the denominator, here cot square x minus 3. Cot square x is present and cot is present in this third fundamental identity. So we put the value of cot square x from this fundamental identity. So cot square theta is equal to, carry this one to the right hand side. So we get here cosec square theta minus 1. So we put here cot square x as a cosec square x minus 1. Only we replace that theta by x. In the problem here x is given. So it is equal to limit as x tends to pi by 6, this 2 minus cosec x divided by, I replace here cot square x by cosec square x minus 1 and this minus 3 as it is. So we get here limit as x tends to pi by 6, this 2 minus cosec x divided by this cosec square x minus 1 minus 3 minus 4. Okay, so we write this as limit as x tends to pi by 6. Limit as x tends to pi by 6. Here in the denominator it is cosec square x minus 4 is 2 square. So we can take the factor of this using the formula a square minus b square. In one bracket it is a minus b, in another bracket a plus b. So cosec x minus 2 is the factor. But here in the numerator it is 2 minus cosec x. So we take here minus sign common. So minus, and here now this 2 become minus 2 and plus cosec x. So firstly write cosec x. So cosec x and then this 2 and 2 become here minus. Due to this minus sign this become plus and this become minus. Okay, and now factorize this denominator. So we get here this is equal to limit as x tends to pi by 6 minus in the bracket cosec x minus 2 divided by cosec x minus 2 into cosec x plus 2. Okay, now we cancel this common factor. Why we cancel? Because we have to write this reason. X tends to pi by 6. X tends to pi by 6 means x not equal to pi by 6. And which factor we have to cancel? This cosec x minus 2. So directly write here cosec x minus 2 not equal to 0. Okay, then we cancel this common factor cosec x minus 2 and this cosec x minus 2. And now here remains minus 1 upon cosec x plus 2. And now put directly x as a pi by 6 because now denominator should not 0. Here denominator becomes 0. If we put here x as a pi by 6, cosec of pi by 6, that is 2. 2 minus 2, 0. So this is the difficulty. We remove that. Because here cosec x minus 2 as x tends to pi by 6 not equal to 0 we have written. So it is equal to minus 1 upon cosec of, instead of x we write here pi by 6 plus 2. Now cosec of pi by 6 means cosec of 30. Now we must know sine of 30. Sine of 30 is 1 half. Sine of 30 1 half. And the reciprocal of 1 half is 2. The reciprocal of sine is cosec. So cosec of pi by 6 is 2. So it is equal to minus 1 upon 2 plus 2. So it is equal to minus 1 upon 4. This is the solution of second problem. In this way we have completed here 4 and 2, 6 problem. Remaining problem we will see in the next video lecture. Okay, we stop here.